Hi physical science students, here we are with the next video. We should have just watched the introduction to ionic bonding, and now we're going to talk about the formation of positive ions. Now the metallic elements, the left hand side of the periodic table, left hand side of the staircase, these guys lose electrons to form positive ions. And so we're talking about this part of the periodic table. These guys, their electron shells are more empty than they are full, so it's easier for them to lose, in contrast to the nonmetals, whose electron shells are more full than they are empty, and therefore these guys it's easier to gain electrons. But in this section we're just talking about these guys here. These are the group 1 elements, group 2, group 3, group 4, so forth. Let's do an example. Lithium. Lithium's group 1 element has electron configuration of 2,1. It wants to get the electron configuration of the nearest noble gas, which in this case is helium, and helium has the noble gas configuration of 2, so a single electron, this guy in the outer shell, is lost. And it now has the electron configuration of helium. It's not helium, it's still lithium. Okay? Why is it still lithium? Because it has 3 protons, and remember, what we call an element is defined by the number of protons, not the number of electrons. So it's still lithium, but now it has a charge of +1. These charges are written as superscripts, so above and to the right of the element symbol, such as this. We don't have to write the 1 there, but if it was a 2, we'd have to write the 2. Some people write 2 crosses, but I prefer to write +2. Let's just look at it visually. Here's the neutral lithium with its electron configuration of 2,1 with 3 protons in here. It now becomes the ion with just the 2 electrons in the outer shell, nice and full, so it's happy, chemically speaking, and this electron goes off and joins another atom or does whatever electrons do. What's it like in words? A lithium atom now becomes the lithium ion, +1 electron. This is how we'd write it as an equation, and we're going from a 2,1 configuration to a 2. Notice here that lithium here is neutral, so there's no charge. Here we have +1 charge, -1 charge, so these 2 charges cancel. So in this equation it's charge balanced. We're not creating or destroying any charge, because we're not creating or destroying any electrons, we're just moving them around a little bit. So this equation is charge balanced. How does the charge of the ion work? Well, for the lithium atom, we've got 3 protons in the nucleus, 3 electrons, so it's neutral. When it becomes the ion, we've still got the 3 protons, but we've now only got 2 electrons, so we have a charge imbalance of +1. This is written as Li. This one has to be written as Li+. We have to write that charge in there because it's different from the atom. The group 2 and group 3 elements contain 2 or 3 valence electrons, and they can lose those as well. And they will lose them to form +2 or +3 ions respectively. And the electron configurations of the simple ions formed are identical to those of the nearest noble gases, and I'll do a quick thing about that in a second. Each occupied shell is now full. By losing those electrons, it has full electron shells. And some examples are lithium ion, just has a single shell with 2 electrons in it. Sodium, because it has more protons and more electrons, it now has the sodium ion now has the electron configuration 2,8, so it's lost its outer shell electron. Potassium has even more electrons. It now has the electron configuration of 2,8,8, lost its outer shell electron. Notice these are all noble gas configurations. Note that when we name a metallic ion, we use the full name of the metal followed by ion, because we need to be able to distinguish it from the neutral atom. So here we have the periodic table. So we did lithium. The nearest noble gas to lithium is helium over here. With sodium, the nearest noble gas is, if we flip it over, is neon over here. And for potassium, the example we did, the nearest noble gas is argon, which has the electron configuration shown before, 288. So the next video will talk to you about how we form the negative ions, and then we'll put it all together.